Hello, everyone. I am Tiffany Williams, and today I'll be presenting my capstone project, Predictive Trust Monitoring System, Proactive Customer Experience Management. Throughout this presentation, I'll discuss the business problem, the methodology I used, and the modeling process, the results of the iterative refinement, and the business value this solution can provide. Project overview. Organizations collect an incredible amount of customer feedback, but most of that information is used reactively. Companies often don't recognize declining customer trust until customers leave negative reviews, stop doing business with the organization, or decide to leave altogether. My project addresses this challenge by transforming customer feedback into actionable intelligence using machine learning. Rather than simply reporting historical survey results, the application predicts trust risk and provides business users with the insights that allow them to intervene earlier. Business problems and objectives. So the primary business problems was shifting customer experience management from reactive to proactive. To accomplish this, I established several objectives. First, to build a machine learning model capable of predicting customer trust risk. Secondly, produce understandable predictions. Thirdly, compare multiple machine learning algorithms rather than relying on a single model. And lastly, to develop a Streamlit web application that allows business users to upload data, analyze customer feedback, and generate predictions without requiring programming knowledge. Ultimately, the project demonstrates how organizations can identify at-risk customers before trust declines even further. System architecture and methodology. I follow the Osman framework throughout development, beginning with obtaining and preparing customer experience data before moving into exploration, modeling, and interpretation. The application was developed in Python using Streamlit for the interface and scikit-learn for machine learning. Rather than evaluating only one algorithm, I implemented logistic regression, random forest, linear support vector machine, and gradient boosting. Using multiple algorithms allowed me to compare performance objectively and select the best performing model instead of assuming one approach would be sufficient. Data preparation and feature engineering. Data preparation was one of the most important phases of the project. The application validates uploaded datasets, handles missing values and duplicates, and performs feature engineering before any modeling occurs. Some of the engineered features include service averages, vehicle satisfaction averages, billing issue indicators, recommendation scores, and customer comments. I also pulled in a unique identifier for customers so that they can operationally be used for follow-up, but excluded it from the model training to prevent any data leakage. These pre-processing steps informed and improved both data quality and the predictive performance. So the baseline model evaluation. I began with logistic regression because it provides an interpretable baseline and serves as a strong starting point for comparison. The baseline model achieved approximately 91% accuracy with precision, recall, and weighted F1 scores all around 91 as well, and a weighted ROC curve of 0.982. These results indicated that the model was already performing well overall. However, I didn't stop at the overall metrics. I analyzed the confusion matrix and classification report to understand where the model was making mistakes. The biggest opportunity for improvement was the medium trust risk class. The model occasionally classified medium risk customers as low risk, which is significant because those customers are often beginning to lose trust but haven't completely disengaged just yet. From a customer experience perspective, these are exactly the customers organizations want to identify early. Improving predictions from this group allows businesses to intervene before dissatisfaction escalates into complaints, negative reviews, or even customer attrition. So while the baseline metrics were strong, the detailed evaluation showed there was still room to improve the model's practical business value. Advanced analysis and model refinement. Instead of simply trying another algorithm, I implemented a structured refinement process. This included hyperparameter tuning, cross-validation, benchmark comparisons across multiple machine learning algorithms, threshold optimization, and feature importance analysis. Each refinement was designed to answer a specific question. So the hyperparameter tuning, it helped determine whether logistic regression could be improved. The cross-validation, it verified that the model would perform consistently across different subsets of data rather than only one trained test split. Benchmark comparisons determined whether another algorithm was better suited for the problem, and the threshold optimization evaluated how changing prediction thresholds affected precision, recall, and F1 score, allowing the model to be aligned with the different business priorities. Together, these techniques ensured that the final model recommendation was supported by objective evidence rather than just assumptions. Model performance and key findings. The refinement process produced measurable improvements across every evaluation metric. Accuracy increased from 91% to 97%. If you see here, at this table, precision improved from 0.914 to 0.972, meaning the refined model produced fewer false positives when identifying customers at risk. Recall improved from 0.91 to 0.96, meaning the model became better at identifying customers who were truly at risk rather than missing them. The weighted F1 score increased from 0.91 to 0.968, demonstrating a much stronger balance between precision and recall. And finally, the ROP curve improved from 0.982 to 0.993, showing that the refined model became even better at separating high, medium, and low trust risk customers. Perhaps the most meaningful improvement came from the confusion matrix. The refined model substantially improved classification of medium trust risk customers. This means that the application became much better at identifying customers who are beginning to experience declining trust instead of waiting until they became high risk. In a real business environment, that translates into earlier intervention, more targeted customer outreach, and greater opportunities to improve customer retention. Benchmark comparison also confirmed that gradient boosting consistently outperformed logistic regression, random forest, and linear support vector machine, which is why it became the recommended production model. Predictions and business insights. This is where the project moves beyond machine learning and becomes a business solution. The application doesn't simply predict whether a customer is high, medium, or low risk. It also provides a confidence score, explains the primary reasons behind the prediction, recommends a next action, and preserves a unique customer identifier so customer experience team can perform closed loop follow-up. One of the most valuable insights came from the feature importance analysis. Recommendation score was the strongest predictor of the customer trust, followed by negative language in customer comments, billing issues, service quality, and vehicle satisfaction. We used Hertz data via Kaggle, so that's why we're looking at vehicle satisfaction data. But these findings align well with customer experience research because they highlight the operational factors that most influence customer trust. Instead of reacting after customers become dissatisfied Organizations can use predictions to proactively prioritize outreach, investigate recurring service issues, and allocate recovery resources more effectively. Ultimately, the value of this application isn't just that it predicts customer trust risk, it's that it provides actionable insights that help organizations make better decisions before problems become more costly. Business impact and future enhancements. While the current application is fully functional, there are several opportunities for future enhancements. For example, future versions could integrate directly with customer relationship management systems and survey platforms to enable real-time trust monitoring. Additional enhancements could include automated model retraining, model drift monitoring, cloud deployment, stronger authentication and encryption, and expanded natural language processing capabilities. These improvements would make the application much closer to enterprise production ready deployment. So, in conclusion, this project demonstrates the complete life cycle of an applied data science solution. It includes data preparation, feature engineering, predictive modeling, iterative refinement, explainable AI, visualization, reporting, and deployment through an interactive Streamlit application. More importantly, it demonstrates how predictive analytics can transform customer feedback into proactive business intelligence. Beyond achieving strong predictive performance, one of the biggest lessons I learned throughout this project is that building an effective data science solution is about much more than achieving high accuracy. It requires understanding the business problem, selecting the appropriate evaluation metrics, validating models through iterative refinement, and ensuring that the results are transparent and actionable for the people who will ultimately use them. This project emphasizes practical decision support, making it a solution that organizations could continue to build upon for real world customer experience management. So thank you for taking the time to review my capstone project. This experience strengthened both my technical and analytical skills while reinforcing the importance of developing machine learning solutions that are not only accurate, but also explainable and practical for business users. So I appreciate your time and consideration. Have a great day.